And welcome to day 3 of the Tech Safari out here in the urban jungle of Atlanta. This is my assistant Kev Bro. We're out here looking for some rare snakes. Let's see what we can find.
Let's go. Oh, what's this? Have you ever seen this before?
Looks like a dinosaur.
It's a dinosaur. Could be a crocodile. No, it's a dinosaur.
Dinosaur school.
I wonder how it breathes.
Well, actually, good thing that you asked. This is a Stegosaurus dinosaur from the late Cretaceous period, and if you want to learn more, follow me.
Let's go.
Welcome. Now that we're situated, let's delve into dinosaur breathing and its cooling effects on the brain. Does anyone of you guys have questions?
Actually, Professor, how are scientists able to recreate the breathing functions of dinosaurs if they're actually already dead?
Good question.
Scientists have been able to use high-powered computer simulations to model airflow through dinosaur snouts. This cutting-edge technology has allowed them to discover that dinosaurs used to use their noses not only to breathe, but have a sense of smell to cool their brains.
You there. Yes, how do dinosaurs' descendants help them better understand the breathing functions of dinosaurs?
Even better question.
Scientists have turned to modern-day relatives such as birds, crocodiles, and lizards in order to provide clues, since their respiratory mechanism is very similar to that of the dinosaurs. Also, scientists have done lots of dissections, blood vessel injections, and CT scanning, but the major tool that has been the most relevant is the use of 3D computer simulations to model airflow in the nasal cavities.
Professor, I'm actually still confused. Could you explain more about the 3D simulations?
Yes, definitely.
Scientists have adopted techniques used in medicine and aerospace industry called computational fluid dynamics. These techniques were used to model airflow in ostriches. In particular, science chose to study Pachycephalosaurs, grass-eating dinosaurs best known for the several-inch-thick bone on tops of their skulls, which was used for display and protection. This extra bone, however, also resulted in ossified tissue in the nose.
How did the scientists figure out that dinosaur noses had olfactory functions as well?
Well, actually,
As the scientists were cleaning up the fossil skull of the Pachycephalosaurus, they surprisingly discovered that in the back of the part of the nasal cavity there were these delicate scrolls of bone that were called nasal turbinates. In other animals, these turbinates were the areas of the olfactory chamber where smelling took place. The problem, however, was airflow analysis didn't show inspired air to flow through the olfactory chamber. Something was wrong.
But, Professor, how is this dilemma solved then?
this brings us to our last point.
Insertion of turbinates of different shapes into various birds such as turkeys or ostriches hinted at the need of a long bony ridge which allowed passage of air into olfactory chambers. This allowed scientists to consider the fact that turbinates function by directing air to the olfactory region and even cooling the brain.
Hello again, friends. Despite continued research, Bork and his team at Ohio University have made significant advances in dealing with nasal airflow and its relation to the nasal structure of modern-day animals such as previously mentioned crocodiles and ostriches. They have been discovered that the hot atrial blood that passes over the turbinates was cooled, and the process resulted in cold venous blood that returned to the brain. This proved very vital for the dinosaur survival.
Yeah.
I learned so much today.
Yeah, I'm glad the good professor taught us about Stegosaurus.
I didn't know anything about them before.
Yeah, I'm glad dinosaurs don't live today anymore, though. That'd be pretty scary. What was that?
Sometimes it's not the test.
Probably. Oh my God!